grown up with a Tamil family.
Yes, sir.
Ayyo, ayyo. Ayyo. Okay, so let's move with the next topic. Okay.
M
So
omega
next,
square इसका formula होगा. नहीं, M omega, sorry.
so next topic is the topic of angular momentum. Okay. So let's talk about angular momentum. So in mechanics, we already studied the concept of linear momentum, and that was mass into velocity, and this was physically the
इसमें
amount of motion.
M omega हो जाएगा.
नहीं, wait,
अच्छा.
something like that, but not exactly. Amount of linear motion. So it represented physically how much quantity of motion do you carry, right? So it was represented by P. But angular momentum is represented by L, but is a vector. Okay, it tells you how much is the. So if linear momentum tells you the amount of linear motion, the angular momentum tells you how much is the turning motion. Okay, how much turning motion you have. That's a quantity it represents. If the amount of linear motion, this is amount of. Okay, so this is. So if you have a particle which is rotating, for example, this is a particle. Okay, it's a particle. Remember, it's not a rigid body as yet for you. There's still a particle, but this particle is now revolving around an axis. So this is the axis around which it is actually. Okay, the tangential velocity is v. The radius of the circle in which it is moving is r. Then the amount is calculated by the formula. L is given by the linear momentum it has. So we are talking about the linear momentum of a particle. Linear momentum of a particle. This is what we are studying. P पढ़ चुके हम. So linear momentum तो हमने पढ़ लिया और what I'm going to write now is the of a particle is known to us, and now we are again studying the angular momentum of a particle. A particle which has a linear momentum p, because the mass of the particle is m. So at this instant, at the point A compared to O, which is the radius, you have a linear. So since it is in rotational motion or revolution, what it has is a turning motion also, right? At any instant, the linear momentum can be found out, and then linear momentum multiplied by the perpendicular distance of the velocity vector from the axis of rotation or revolution. So this is your axis around which you are revolving, and here you have a linear momentum, which is this, and then multiply by the perpendicular distance of yours from the axis of rotation. So perpendicular distance is the radius, and therefore linear momentum multiplied by the perpendicular distance from the axis of rotation. P multiplied by R. MVR. Written as P M V cross R actually. Okay. So when you talk about the vectoral form, this is the vectoral form. So it is P R cross P. Sorry. Okay. It is R cross P. So it's a vector. Chalo, let's just stick to the. Let me not write. So let me just say this is L, and L is given by the product of R. It is actually R cross P. ये उल्टा लिखा हुआ है, but ये मतलब product है ये. This is the actual product. But if you write it vectorially, then it is the linear momentum vector multiply with the perpendicular. I think r comes first and linear momentum comes later. So let me just reverse the sequence. Either let's write the vector. Okay, so let's write the vector r cross p. Okay, so this is your r and this is your v. So if you move from r to p,
to p, अच्छा मतलब ये क्या कहते हैं, ये एंटी क्लॉकवाइज है
yes,
तो
because you're going from r to v as an anti-clockwise, so this
वो
is a
अपवर्ड
direction of
लगेगी ना,
upward.
अपवर्ड
Yes,
लगेगी,
ठीक है,
upward।
fair enough. So if we talk about magnitude, magnitude is m
तो कॉक्स क्यूब
p.
रूल ऐसे लगाते कैसे हैं?
Just use your hand and curl it along the from if you want to use this. If this is your r and this is your v, then open the cork like this from r vector to v vector. Okay, अब
अच्छा ओके,
ढक्कन को ऐसे खोलो from r to v. So if it's opening,
और अगर B2 आ रहे तो उसको
तो नीचे की तरफ,
नीचे की तरफ,
then you're clockwise, right? You're closing it. ढक्कन को बंद कर रहे हो.
दोनों एक
So
ही
that,
रूल है एक्चुअली।
yes, yeah. So if you want to find the direction of L, that's the way you do that. And if you want to find the magnitude, MBR sine theta. Okay, that is the way the angular momentum is found out. ठीक है? Okay, now let's talk about special cases when theta is equal to 0. So V and R are in the same direction. ये velocity और R एक ही direction में हो जाएंगी sin 0. So angular momentum will be equal to 0. No turning momentum is there. If the line of action of linear momentum, so this is a line, ये mv अगर मैंने ऐसे बनाया velocity and this is m, so this is p is equal to mv. So this mvp is the line of action of the linear momentum, and r also is in the same line. No turning is happening actually, right? So you need to have this perpendicular distance available to you. तो ये जैसे इन दोनों के बीच में ये इंसिडेंटली 90 डिग्री था, तो ये सीधा इस सर्कुलर मोशन में साइन 90 बन जाता है. वैसे थीटा इज इक्वल टू 90, आई एम रेफरिंग टू अ सर्कुलर मोशन बिकॉज इन द सर्कुलर मोशन velocity and r are at right angles. So this is a typical case of circular motion. The answer is mvr sine 90.
मैक्सिमम एंगुलर मोमेंटम,
Correct. And theta is equal to 180 degrees. Okay, just sine 180 is again 0. So L is equal to 0. At any other angle, if you get some angle, so put sine theta and you will get the answer. So that's your maxima. ठीक है जी? This is called the position vector. What is the position of the body which is moving, turning with respect to the axis of, so from axis of rotation, take the origin and draw the vector. So that will give you the direction of the the position of the particle with respect to the axis r distance way up. Okay, so if you are at r distance, this is the way you will calculate it. Okay, physical meaning I hope is clear to you. It's a turning quantity, which is what
अमाउंट
it
ऑफ टर्निंग,
represents. Yes, amount of turning you can say. Okay. Yes,
एंड टॉर्क इज फोर्स इनटू द क्या कहते हैं परपेंडिकुलर डिस्टेंस।
yes. That is a turning capability of the force. So a torque actually provides the turning. Torque has the power to provide turning, and if turning happens, angular momentum is imparted. So torque is a source of angular momentum.
तो ऐसा कोई रिलेशनशिप है कि क्या कहते
Yeah,
हैं एंगुलर मोमेंटम और
think
टॉर्क?
in terms of, yeah, of course. So think in terms of linear motion, where you say force is proportional to rate of change of
Momentum.
Momentum. So if there is a rate of change of momentum, rate of change of angular momentum also, you have a torque, which is a rotational force.
Okay. तो ये भी सेम है जैसे कि like
Huh?
dl by dt
Yes,
equals to tau.
tau. That is correct. So you can say that the
यू
torque
यूनिट क्या
is
होती है टॉर्क की?
Newton meter, force into
न्यूटन
force
मीटर
arm,
ये? ठीक है.
right? So other is you earlier we have written torque as R cross F. This is your torque. Okay, and angular momentum is given by, you can see, R cross P. Right? If you differentiate both the sides of this, dl by dt is equal to d by dt R cross P. Okay. dr by dt multiply by P plus R into d pi by dt.
dt is equals to
This is what? Velocity, instantaneous
well,
velocity, multiply by the momentum plus R into, if you know what is dp by dt equal to force, ठीक है, R cross F.
ये आ जाएगा आपका क्या कहते हैं टॉर्क.
V और P की डायरेक्शन देखो क्या है, थीटा इज इक्वल टू 0 डिग्री, वेलोसिटी और मोमेंटम की डायरेक्शन एक ही होती है, थीटा इज 0, so cross product is 0. The only thing you're left with is dl by dt is equal to R cross F.
अच्छा, तो ये डेरिवेशन.
Exactly, top. Derivative, yeah, but what you said exactly is this derivation. So you can see the relationship dl by dt actually comes out to be R cross F. This is where we started, right? And I told you torque is equivalent of force. This is the torque getting applied and producing a rotational rotational turning, which is coming in the form of change of turning motion. So torque is actually given by, like you said, dl by dt. Okay.
Hence proof.
So yeah. So the rate of change of angular momentum is the torque. Okay. Okay. So let's move on to the what is the geometrical meaning of geometry, मतलब parallelogram represent करता है, ये क्या करता है? Okay, geometrical meaning of angular momentum. In geometry, if you had two sides of a triangle or something that, you know, area under it is the product of R cross F. What does it represent? So R cross F actually represents, so if you have a x, y, j coordinate system, which is this y, this is your x, and this is your z, and this is your, for example, you have a situation of xy plane, which is this is your xy plane, right? This is your xy plane in which you have R and F, and the body is at certain position and then it moves in the xy plane from some point to some point. So this is the change in position of the body represented by delta R. Its earlier position was this, and now the new position is this. So the difference of the two is this delta R, change in position. This is R plus delta R. It
A small change.
Yes. Okay. So ये delta R हो गया, ये resultant आ गया R plus delta R दूसरा. Now, if you have to write what is the velocity at the point P, there is a velocity at point P, there is a velocity at point Q. And if you look into this diagram and you have to find the if you draw a parallelogram for this, okay, and you draw a line which is parallel here to this, ये इस delta R के parallel बना के ये line खींच दो xy plane के अंदर, so this is delta R, this is something like a law of parallelogram, और ये इसके parallel है. So इसको अगर आप ध्यान से देखोगे, then the area of the triangle PQO, if you see the area of triangle OPQ,
Half into.
OPQ is equal to half
into
R
delta.
हाँ
Okay.
so
Delta
this
R.
is yes half base into perpendicular. So this is and if you notice the R and तो ये तो parallelogram है जो पूरा बना हुआ है ये वाला. Let me just color it down. Okay, let's color this. This is your parallelogram which I've completed. Okay, so parallelogram का जो area है that is given by R into delta R. Vector product of two vectors also represents the area of parallelogram enclosed by the two vectors. So if you have A and B and you want to find the vector product, although you say the vector product is this depending on you moving from A to B or B to C, but if you complete the parallelogram like this, right, then actually A cross B, the two vectors, they represent the area under the curve.
तो डेल्टा आर क्या होगा?
Jira,
बस
change in position, that's all.
अच्छा.
Right, तो मैंने दो ट्रायंगल को आधा कर दिया ना. Actually, the area of the parallelogram was R into delta R. If you notice the parallelogram, if I draw OPQ, for example, this is R. So if मैं जिसको dark कर रहा हूँ, notice it. I am darkening the parallelogram. Can you see the parallelogram getting darkened? Right? This is the parallelogram being referred to. And this is the hypotenuse. And the area of this parallelogram is this. So both the triangles are equal. Therefore, I have made the area of the triangle OPQ, which is the left triangle, okay, which is I'm marking by green. So this triangle's area is half of the area of the parallelogram. Right. So delta A, which is the area of the triangle, is half the area. So this is the area of the parallelogram, and half of it is the area of PQ. Okay. Now, if you notice, the delta R is basically what? Delta R and is a change in position in time t. So half R cross V into delta t, right?
ठीक है.
Because change in position is velocity into time. And now you know P is given by M into V. This already we know.
अच्छा.
Velocity can be written as P by M, and therefore the area of the triangle becomes half R multiply by V की जगह मैं लिख रहा हूँ P by M into delta T. And delta T is a number, so I will take it on the other side. So this will become delta area upon delta T is equal to half of 2M. I will remove this. So this, sorry, अभी नहीं ले जाता मैं. Let me take it in the next step. Let it be this. And now let us take delta A upon delta T is equal to half R cross P upon M.
दोनों साइड्स में लिमिट्स ले लें.
हाँ जी.
बस इतना लिखना है, डेल्टा ए बाय डेल्टा टी.
हाँ, M भी बाहर लिख सकता हूँ मैं. 2M R cross P. So this is delta A by delta T. This quantity is what? L, right? So the delta area divided by delta T is equal to 1 by 2M into L. So
सर
therefore, L comes out to be 2M multiplied by delta A by delta T.
ज्योमेट्री
Yeah.
कंफर्म.
Yes. So
T.
if you notice, the vector you drew R is moving.
अच्छा आपने ठीक है.
So ये जो वेक्टर था ये वाला जो R वेक्टर था ये थोड़े टाइम में it has swept the area delta A. भाई मैंने तो I drew it like this, right? I said this is my scenario. This is my scenario and this is R and ये आप हिला के यहाँ पे ले आए हो, right? Delta R. So this is the delta R, right? And this is R. Just notice that in small delta time interval, how much area the position vector has traversed. ये वेक्टर ए वाला जो वेक्टर है आर, ये झाड़ू मारता हुआ स्वीप करता हुआ ऐसे गया और इसने ये छोटा सा ट्राइंगल बना लिया, राइट?
ठीक है,
It has
ये समझ
swept
आ
the
गया.
area. We say the word swept the area. So you can see the angular, so delta A by delta T, if you notice, is nothing but the area swept by the position vector in time t. So delta A by delta T is the rate of sweeping the area per unit time, and this is called as the areal velocity. Area ki velocity. Generally, velocity is position x upon t, right? dx upon dt. But here we're talking about dA by dt. The rate of, we call it a areal velocity on the left hand side is the word. Angular momentum, right, can also be written as angular momentum can also be written as 2 times the mass multiplied by the areal velocity of the position vector, which is sweeping as the body is moving. So this is a geometrical meaning that the area, the angular momentum of a body is twice the product of its mass and its areal velocity. Or we can say the
Areal
areal
velocity.
velocity is equal to areal velocity can also be written
Areal
as
velocity से अच्छा.
areal velocity
Area
can be written
upon time.
as exactly. Uh, L divided by 2m, right? So this is
Yep.
angular momentum per unit kilogram. The angular momentum per unit kilogram is called as the areal velocity. And you will see in gravitation chapter where you do actually see these areal velocities, because there what you have is a conic figure like this, and in the on the foci बोलते हैं जिसको, you have a situation where the planetary जो body होती है जो sun के around घूम रही होती है, so what happens is वो जो body है वो मान लो उसकी मैं शक्ल, let me draw a circle with here, okay, so that's your planetary body. These two are focus. Let me just show you the focus. Let me represent focus with different colors. The greens are the focus. Okay, focus. And the body is
क्या
moving.
ellipse
So
है क्या?
it's an ellipse. Okay, and so the area which is swept by this body is this much. Okay.
This is area velocity in time
Exactly.
t.
Exactly,
ठीक.
right. So this areal velocity has to remain constant for a planet, but R is changing. इसमें जो sweeping के लिए what you have R is different from this one, right? This is a longer R,
Okay.
right? So this is the concept of dA by dt. Practically, when you see the Kepler's second law is when you encounter the concept of and remember the
अगर यहाँ पर आ जाता है तो R ये हो जाता है.
yes.
और ये फोकाई क्या होता है वैसे? ऐसे ही पूछ रहा हूँ.
So the sum of distance, okay, in the case of an ellipse from the focus of points on the ellipse जो xy coordinate है is represented by x square by a square plus b square by I think it's y square by b square is equal to 1. Okay, it's different from a circle. तो सर्कल पे तो यू नो द डिस्टेंस, बट अगर आप कोई भी पॉइंट एक्स वाई कोऑर्डिनेट लोगे इसके ऊपर, ओके, और ये इसके दो एक्सिस हैं इसके, देयर आर टू एक्सिस, अ माइनर एक्सिस एंड अ मेजर एक्सिस, इफ एंड दिस can be A or B, whatever. So this is A and this is B. So this is A, this is B. Okay, A and B. So this is your x square by A square upon plus y square by B square is equal to 1. ये जो पॉइंट आपने लिया है इसके ऊपर, if you calculate the distance of this point from A ये वाला जो distance है, if you calculate this, the sum is always this, x square upon a square. To take any coordinate on a ellipse, it will satisfy this. A is the length of the semi-minor axis, B is the length of the semi-major axis. So if you calculate the distance of this point from the center, you will find this equation being satisfied. Let me exactly tell you the definition of a ellipse की वो distance focus से कैसे नापते हैं हम. Locus बोलते हैं collection of points which satisfy a certain equation.
लोकस
Okay.
है.
So calculate the distance from the first focus, not from the center, but
Focus
from
is
here.
equals to locus.
No. Locus is different. ये वाला distance है. So this is distance 1, and this is distance 2. Distance 1 and distance 2. Calculate these two distances. The sum of these two distances on any point is constant. If you take this distance, calculate this distance and distance from the second focus, the sum of these two will remain constant. Take this point, this distance and the distance from the second focus, f1 and f2. So this distance plus this distance, irrespective of the point you take, remains constant. And this equation represents the equation of a ellipse. So it is not from the center but from the two focus. Center तब होता है जब circle होता है, तो वो focus तो एक ही होता है वहाँ पे. So the planets move in a elliptical motion like this. There are two foci.
ठीक.
अभी पढ़ेंगे when you do conic section in detail. Locus का मतलब होता है collection of a point that satisfies a given condition. So if you see all the points x, y satisfy one equation, which is x square by a square plus y square by b square. These points are organized in such a way that if you take the sum of their distance from the focus, that sum of the distance remains same. All the points on this ellipse follow that. So the collection of all the x and y which satisfy the equation is called as locus, and when you solve this mathematically, algebraically, you get an equation like this. Locus का मतलब होता है collection of points. If you have a circle and you say what is the, write the equation of locus of this, the circle की equation अगर आप लिख देते हो, it's a collection of point on the circle with any coordinate x, y, and this circle is centered at R. This represents any point x, y, such that the distance from the center is equal to the radius square. Pick up any point on the circle. The x square plus y square will always be equal to radius square. All these points together constitute locus. They represent a collection of points that satisfy a equation, that they have to be at same distance from the center of the circle.
थोड़ी
From
बहुत
a
ऐसी
point.
लग रही है कहते हैं पाइथागोरस थ्योरम जैसी.
कह सकते हो, something very similar. Pythagoras is also something very similar, but not exactly. Locus थोड़ा सा word जो है, it's meant for collection of points that satisfy a given equation. All right, let's move forward on this. So now, but you don't have to really worry about the geometrical meaning of angular momentum. If you understand it, we will come back to it in detail because we have to apply it in the second law of planetary motion. Kepler's के जो law पढ़ेंगे उसके अंदर, ठीक है? तो aerial
ग्रेविटेशन क्लासिकल
Gravitation.
मैकेनिक्स है कि एस्ट्रोफिजिक्स है?
कोई एस्ट्रोफिजिक्स नहीं है हमारे यहाँ पे, जीरो.
तो क्लासिकल मैकेनिक्स है वो.
हाँ,
स्पेस
सारा
की
सारा
चीजों पे
नहीं
डिस्कस
नहीं
हो
वो
रहा है.
न्यूटन द कंट्रीब्यूशन आल्सो केम फ्रॉम न्यूटन.
बट मेजर कंट्रीब्यूटर्स
Kepler.
जोहान केपलर थे.
यस, केपलर. बट न्यूटन तो पता ही है कैसा, मतलब हर
हर चीज
जगह.
में टांग घुसो रखी है उसने.
हाँ, तो वो ही हैज कम डाउन
तो
एंड
केमिस्ट्री में भी घुस हो देता वो तो.
वो कुछ भी कर सकता था.
गॉड
So
ऑफ
this
साइंस.
is, yep, can say that. This is one, and let's talk about now the concept of, okay, so planetary motion में तो you will see it, okay, so dA by dt concept.
सेंटर ऑफ
This is
मास यूज
bound.
होएगा उसमें
किसमें?
ग्रेविटेशन में.
नहीं उस पे obviously sun and earth are located at this distance.
रोटेशनल
लेकिन
मोशन.
हाँ होगा थोड़ा सा सेंट्रीपिटल, दैट्स ऑल.
अच्छा.
Yes. So if you notice the in the context of planetary motion, this is okay. So in equal amount of time, equal amount of area is swept. Okay. Yeah. So you can see, right, the sun is there and planet is moving around the sun, and you can see the areas being swept by the position vector A to B, then from C to D, and if the time interval is same, the and by the way, the planet has an angular momentum MVR exactly because theta here is always 90 degrees.
Okay.
So ये आपका position vector है body का. Position vector is drawn
ये
from
रेडियस है.
yes center से.
अच्छा, सेंटर से, फोकाई से.
Origin से नापोगे ना position तो.
ओरिजिन
या
कहाँ है
sun
इसमें?
से नाप लो. If sun is origin, then measure it from sun. Sun is
नहीं.
at one of the focus. Yes. So you have to draw it from. R is the position of the vector of the planet position with respect to sun in the formula. Yes. R से बनेगा. With respect to sun है.
परपेंडिकुलर.
MVR. So angular momentum is MVR. So there is no external torque which is acting. So angular momentum will remain conserved in this case.
अभी एंगुलर मोमेंटम की कंजर्वेशन भी करनी है.
हाँ. क्योंकि अभी तो हमने सिर्फ देखा what is angular momentum, right? And we have understood that the rate of change of angular momentum is torque. So torque is going to produce a change in angular momentum. More turning will be there, and hence the torque will produce angular acceleration, just like force produces linear
So
acceleration.
torque is basically directly proportional to the angular momentum. Yeah.
The rate of change of angular momentum is equal to torque. So torque is proportional to rate of change of angular momentum.
Okay. Directly.
Yes. All right. So let's say you are given a situation like this where the particle has a torque acting on it, and you know torque is a vector. Okay, so you can use this dl by dt. You can also use r cross f. So if I tell you the torque resultant has come out to be some value, for example, 2i plus 5k minus 7j, the torque acting on the body is this much, and it is acting about the origin, and the particle is located at some position which is given by r is equal to I plus j plus k, and the torque is acting about the origin, and the r, the position vector of the particle, is given by this. Question is, what is the sorry so this is the the origin के around torque क्या force लग रही है. Okay, so let me just rub this off. Okay, so the force acting on the body is this about the origin, and this is the position vector of the body. So this is the position vector of the body in 3 dimension. Okay, so this is your, if this is your I, J, and K, so body is located somewhere here in 3D. There is a force acting, which is this. You have to find the torque acting on the body, R cross F, which means you should know how to take the determinant and
कल ही
calculate
करा
the
था वैसे हमने.
I,
नहीं, कल
J,
नहीं,
K.
परसों.
ठीक है, so I think you know this. Okay.
डिटरमिनेंट मेथड से हम निकालने.
Yes. So use the determinant vector and find this vector product
इट इज आर
for the
क्रॉस
torque.
एफ ना.
Yes.
आर से एफ में जा रही है.
Yes.
मतलब ऊपर की तरफ.
नहीं, ये यहाँ तो डायग्राम बनाना पड़ेगा आपको R और F का. यू कांट मार्क इन 3D. 2D होता तो बहुत आसान हो जाता, लेकिन 2i plus 5k तो
फिर तो मैं कहते
I और J हो गया.
3D एंगल क्या कहते थे उसको?
वो that is solid
Radian.
angle actually. Solid angle.
Solid
Solid
angle.
angle. Like a angle inside a cone. So this angle is a solid angle.
स्टब रेडियन, कुछ तो ऐसा नाम था
Exactly.
इसका.
Yes. Sterdian.
स्टर्डियन.
Yes, that's correct. Okay, so let's do one more question. We'll do some. We also did equilibrium. So some questions.
Equilibrium of rotational
So
motion.
question number 2, for example, you have a um,
सीसॉ बना रहे हो क्या?
हाँ नहीं मतलब ये pivot यहाँ पे stand लगे हुए हैं तो so it is standing here with the help of some supports and so there is a normal reaction here okay, क्योंकि यहाँ पे touch हो रहा है contact forces will come into play and this is a rod and at the point P you suspend a weight. Okay, so you
Right.
suspend you suspend this weight. Okay, so weight is suspended and at the center I'm sorry, at the center of the rod also there's a weight of the rod itself, which is W. Okay, so this is W and this is W1. This is the normal reaction. I'm sorry. I'll just get some water. Okay, so it is given to you that this is A, this is point P, this is center of gravity.
Center of
This is
gravity
yeah,
is center of
center of
mass.
mass. एक ही बात है आपके लिए. AB is given to be total length of 100 centimeter. AG obviously is 50 centimeter. AP is 40 centimeter. PG is equal to 10 centimeter. And you're given AK1. Okay, AK1 is equal to on both the sides, the placement is identical. So let me just make the placement to be identical. So AK1 equal to BK2 is equal to 20 centimeter and K1G K1G is equal to K2G is the balance. So you know that balance distance nikal lo. Question is what are the normal reactions? And the mass of the rod is 4 kgs. 4 kg is the mass of the rod and the weight which is extra weight which is hung is 10 kgs. Mass of the rod is 6 kgs. Just give me 1 second. So apply the rotational equilibrium because there is a tendency for it to go up and down like this. It's a rigid body. Apply that. Okay. Any questions written?
अरे सर बस एक मिनट लिख रहा हूँ.
So you know the normal reactions, right? So one normal reaction. So दो vertically and downward और दो downward weight है. Reactions are upward. So vertical motion तो balanced है, rod उड़ के नहीं गई है. So R1 plus R2 has to be equal to the weight of the rod and the extra weight at P. Weight of the rod is 6 kg, right? So R1 plus R2 is equal to 16G. This is 1. Now you can see you can pick up any point and apply the equilibrium around that point, rotational equilibrium, which is the multiple torques which are acting. Pick up any point where you want to pivot it. ये जैसे यहाँ पे
K1, K1.
कोई भी ले सकते हो. That is your choice. You don't have to worry because about every point there is a balance, right? There is no rotation happening around any point. But if you want to take K1, you're comfortable with K1, take K1. Yes, go ahead. डरना नहीं है, so आराम से करो. K1 ले लो, चलो ठीक है. So let's say this is your K1, right? Port. तो रिएक्शन तो इसकी वजह से तो कोई टॉक नहीं है because the line of action has no perpendicular difference from the point.
K1 plus K2.
What is K1 plus K2? K1 and K2 are positions. ये निकालनी है आपको. पहले तो आपको मार्क करना चाहिए ये कितना है. How much is this?
This
50.
is 50. 50.
50,
AG
right?
50.
This is also 50.
But AP is 40.
Center है ना?
हाँ जी.
A, हाँ. So this is 40. Okay. So how much is PG? 10.
10. This is 50. अच्छा.
So if you take
R
this point, so you have to apply torque. एक ये वाला torque लगाना है, downward, एक ये लगाना है, और एक ये torque लगाना है जो इस तरफ लगेगा. ये दोनों torque इस तरफ लग रहे हैं. So they are K1 के around ले रहे हैं ना? You're taking around K1. So what will be the torque produced by W1 around K1? W1 into how much is K1G?
K1G.
कितना आएगा?
K1G is equals to K2G. दे रखा है.
हाँ दिया हुआ है, बट निकलेगा कितना? ये दिया हुआ है. AG कितना दिया हुआ है?
AG सर
AG
हमें
दिया है
50 दे
50 सेंटीमीटर. AK1 दिया है ना, ये 50, ये 20 तो दिया हुआ है. ये दिया तो हुआ है.
अच्छा.
AK1 is also
AK
known to us.
20 ठीक है.
हमें क्या निकालना है?
ये 20 है.
K1
ये 20 है. तो K1 से KG हो जाएगा 30.
30. तो ये हो गया 30.
30 is equals to K.
हमें W1 से निकालना है डिस्टेंस.
ठीक है.
हमें W1 से डिस्टेंस निकालना है K1 का. कितना आया? W1 से निकाल रहा हूँ मैं. आई एम फाइंडिंग द टॉर्क बिकॉज ऑफ W1 around this point. How do I find this? 20 centimeter हुआ ना डिस्टेंस. This 20 centimeter is from where to where? K1G है या ये W1 वाला डिस्टेंस है? K1W. I think it's K1G which you have calculated to be 20 centimeter.
नहीं.
या 30 है वो.
It's K1G is 30.
Okay, so right 30
K1G
है.
30 है.
So what is K1W1?
K1W1.
20.
K1W1 is 20.
20.
हाँ जी.
In this direction, right?
Yes.
And what is WK1?
WK1.
WK1 distance? 30.
WK1. हाँ जी.
This is 20.
सर
Center से तो
WK1 और
30 बचा.
K1W एक ही तो चीज है.
हाँ एक ही बात है. 30.
हाँ जी.
So these are two clockwise torques, and anti-clockwise torque will be equal to
माइनस में होंगे.
यहाँ से आ रहा है ना.
हाँ जी.
So clockwise torque is equal to
K2
anti-clockwise
W2
torque.
K R2 K2 सर आएगा.
ये 30 है.
हाँ जी.
और 30 और है. 60 हो जाएगा।
30 नहीं, हाँ 30 है
30 + 30
इसकी। ठीक।
अबाउट K1 लिया हमने।
ओके।
Okay, let's put the values, and this is W1.
W1 is
This
6.
6 into
Say 2
20
times uh, 6 ग्राम था क्या, ये 6 केजी था?
kg।
तो हमने 100 से,
सेंटीमीटर है ना ये?
अच्छा मैं सेंटीमीटर में था, ठीक ठीक। मतलब मीटर में।
1.2
0.6 R2 आ जाएगा 2.4 अपॉन 4 meters।
एक गलती और हो गई। आई थिंक वी शुड हैव मल्टीप्लाइड बाय 10 आल्सो। जी भी तो
ये
होता
वैसे
है।
क्या फर्क, मतलब ये आ जाएगा सर 24/6 विच इज 24/0.6 विच इज 40।
4 न्यूटन
40
और 4
मीटर।
न्यूटन का फर्क आ जाएगा। So now you know
40
for
मीटर।
one of the reactions R2 what will be R1 equal to, sorry, 16 into 10 कर देते हैं, 160 हो गया। So R2 is equal to 40, R1 is equal to doubts in your mind समझ नहीं आया? If you select K2 still you will get the same answer. The torques around that will also be balanced because it is
यस
not turning about K2. It is also
समझ आ
not
गया।
turning about K1. कहीं से भी turn नहीं कर रहा ये।
ठीक है, समझ आ
और
गया।
ठीक है जी, बढ़िया। So let's go with the question number 3. Again to do
ये
with,
बहुत अलग है डायनामिक्स से काफी ज्यादा।
दोनों फैक्ट्स लेने पड़ते हैं इसके अंदर इक्विलिब्रियम के। So this is, अच्छा, it's we're losing our, so let me go to the next page, and this is my wall,
सर एक चीज
and
बताओ, काइनेमैटिक्स भी क्या उसके पार्ट है क्या, डायनामिक्स क्लासिकल मैकेनिक्स की?
here one is kinematics. It is dealing with motion is happening, right?
हाँ जी। डील-
Dynamics deals with y, so it includes force, etc. Yeah, this is motion is happening, s is equal to ut plus half at square, etc. खत्म। Why is this happening? पता नहीं। Acceleration कौन दे रहा है? पता नहीं। Velocity कौन दे रहा है? पता नहीं। जब काइनेमेटिक्स से डायनेमिक्स में आ जाते हैं तो दोनों मिला के you can call it mechanics,
ओके
but they're branches of mechanics.
ठीक।
So this is a ladder, okay? This is a ladder. The ladder is 4 meters long.
अच्छा ये डंडा है, ठीक है।
Ladder, सीढ़ी, पेंटर यूज करता है जो।
कल भी आपने पेंटर वाला कराया था।
हाँ, so now it's a real question, and the weight of the ladder is 20 kgs.
अच्छा, अब क्या पेज टू
This
पे आ गया क्या? अच्छा पेज टू पे आ गया।
weight of the ladder. Yesterday I just gave you a glimpse किस तरह के क्वेश्चन आते हैं, but this is an NCERT question, okay? And what you have to find is now tell us the reactions from the coming from the wall.
ठीक है। इन हो जा रही है। ओके
Calculate the reactions coming from the wall.
अच्छा
Okay, so the length is given. That you need to know the dimensions. For example, this is given to be 3 meters. This is given to
सर
be
एक
4
रिएक्शन तो यहीं से
meters. Draw the diagram. ठीक है, सही बोल रहे हो. There is no friction.
फ्रिक्शन नहीं था
नहीं है. So frictionless है. No friction is there.
फ्रिक्शन अच्छा ये ना एक नॉर्मल रिएक्शन तो यहीं से आ रहा है
हाँ जी.
और एक लैडर का अपना ही वेट है
Hmm.
तो ये नीचे ग्राउंड की तरफ से भी आ रहा है
Okay. Show it above. ये तो वेट है. हाँ, नॉर्मलाइजेशन. ठीक है. N2 सही है. द वेट इज 20 kg. वो उसके सेंटर ऑफ मास पे बना लो. 20 kg डाउनवर्ड.
ठीक
लैडर के सेंटर पे डाउनवर्ड 20 kgs.
ये लैडर का सेंटर ऑफ मास
हाँ ठीक है. 20 kgs 20 g.
20 जी नीचे की तरफ दिखाओ ऊपर ऊपर की तरफ दिखाना
नीचे नीचे यार. वेट इज बीइंग पुल्ड
अच्छा
डाउन बाय द ग्रेविटी. ऊपर कैसे वेट
पॉइंट
लगेगा?
नहीं ठीक है 20 जी
यस.
सेंटर ऑफ मास पे वो लग रहा है अब सर क्या करना था इसमें क्या कैलकुलेट करना था
नॉर्मल रिएक्शंस.
अच्छा ठीक 1 मिनट
नो प्रॉब्लम. आई थिंक यू शुड ग्राउंड पे नॉर्मल अगर वो है फ्रिक्शन, यू शुड शो दैट आल्सो. Okay, wait.
एफएस
Hold on. So just be very careful, and that is why I didn't elaborate this yesterday. If there are two forces, one is a normal reaction, which is leftward, and a friction, तो ये ladder तो इधर चली जाएगी ना,
हाँ जी
तो वो जा नहीं रही है. So there has to be something which has to prevent N1 for static equilibrium. तो friction is here.
ओ
ये स्लाइड होके इधर बॉडी की जाने की टेंडेंसी, जब ये नीचे की तरफ आएगी तो स्लाइड होते हुए इस तरफ जाने की टेंडेंसी है, लेफ्ट टुवर्ड्स. सो फ्रिक्शन विल बी राइटवर्ड. इफ इट कम्स डाउन, ऊपर फ्रिक्शन नहीं है.
तो N1 प्लस
एन N2 रख लो, या तो उसका नाम अगर N1 है कुछ तो N2. N1 N2 तो वैसे ही एक्स और वाई में उनका कोई लेना देना नहीं. N1
plus
No, you
N2.
can't add them because they're in X and Y. How are you adding X and Y forces? Not clear. You write X axis forces separately equilibrium and Y axis is separate. Resolution तो पता है ना?
हाँ,
Why are you putting X and Y together is not clear. How do you add the X and Y? You can add I as in and J's. Why are you writing I and J together?
no.
Equilibrium is in X axis and Y axis.
Yes.
So the sigma X of forces in X axis is 0. So normal reaction is equal to friction. N1 is equal to F. These two gone.
And N2 is equals to
N2, what is this? What is this?
mg.
Says who? mg यहाँ थोड़ी ना लग रहा है. mg तो यहाँ लग रहा है. Vertically, what is the two y forces now? Sigma f x is equal to 0 or sigma f downward x मतलब fy भी 0 हो जाएगा. Net force should be 0 for static equilibrium in y. So n2 will be equal to 20g.
And N1 equals to F.
Right.
So F तो अच्छा ठीक.
Now, so you found some equations 1 and 2 from what? Static equilibrium. Normal equilibrium से निकाल लिया हमने ये. Now what will you do? You will now start doing. So translational equilibrium part is over. X and Y part. Okay, so you've taken care of the translation equilibrium. So in x-axis and y-axis, you have written the two equations, 1 and 2. So translatory, which is x-axis and y-axis equilibrium is taken care of. And now you're worried about the rotational equilibrium, for which you can assume any point about which the torque will remain constant or get balanced. Not constant, balanced from both the sides, anti-clockwise and clockwise. Typically pick up a point where you find a lot of forces acting. Here, for example, this point. So there is no torque due to N2 and F if you pick up this point.
ठीक है.
Easy हो जाएगा ना, दो force तो खत्म ही हो जाएंगी. So you will have N1 and the weight only to worry about. So N1 is trying to rotate it like this and the other is trying to rotate it like this.
N1 और is 20g.
N1 is 20g. How so?
नहीं मैं बोल रहा हूँ N1 और 20g.
Or means
मतलब
you are going to take the talk about this point. What is the perpendicular distance of N1 from this point? 3 meters. Force into perpendicular distance between the axis and the line of the force. The line of the force is N1, horizontal leftward.
Yes, sir.
What is its perpendicular distance from the point about which you
3
are
meter.
applying the torque? 3
3
meters. लगा दो. Anti-clockwise.
ठीक है. तो N1 into 3
Yes. Is equal to
is
200
equals
into
into N2.
what is
No.
N2? Perpendicular distance. Torque का formula होता है force into force arm. Why will you write N2 again?
Sorry.
Now
it
the
is
distance. What is the perpendicular distance of this line of force? Which is this. This is its
4
perpendicular distance. 4 तो
4
पूरा है.
meters.
4 तो पूरा है.
अच्छा.
It is right at the middle.
तो अच्छा.
Similarity.
Okay.
2 meters.
2 meters.
N1 आ गया.
N1 आ जाएगा 400/3. Okay.
Right. So FV आ गया.
हाँ जी.
N2 निकाल लिया है.
हाँ जी. F तो आराम से निकल जाएगा.
एफ तो निकल
सही।
गया, इक्वल टू है एन
हाँ
के,
जी।
n1 के बराबर ही है, निकल गया जाएगा। n1 इज इक्वल टू एफ की वैल्यू भी मालूम चल गई है।
यस सर।
नाउ द क्वेश्चन इज, सारे निकल गए, सो यू फाउंड बोथ द रिएक्शंस, राइट?
यस सर।
Okay, now please find the normal reaction at the point. Sorry, resultant force at the experienced by the ladder at this point.
N2 पे टॉर्क निकालिए।
Resultant force.
हाँ जी।
Torque नहीं बोला, force.
अच्छा
Resultant
4।
force.
ठीक है।
Translatory.
तो ये है फिर N2 इक्वल टू 20 G।
Hmm. Good. So look at this. So wherever it is having a contact, there is a friction here, and there is a N2. So resultant is sum of these two.
ठीक। This
N2
is
square plus F1 square, and the direction
N2।
is tan theta is equal to N2 by F.
ठीक है।
नहीं समझ में आया? रिजल्टेंट, दो फोर्स
अच्छा
लग रही है उस पॉइंट पे भाई, रिजल्टेंट लॉ ऑफ पैरेललोग्राम।
अच्छा, वो निकालने को बोल रहे थे आप।
इसलिए बोलते हैं असाइनमेंट पूरी करो, समझ में नहीं आता कोई आइंस्टाइन भी आके पढ़ा देगा, अपनी असाइनमेंट नहीं करोगे, नहीं आता करने। रिजल्टेंट नहीं पता निकालने दो फोर्सेस का, ए स्क्वायर प्लस बी स्क्वायर, पाइथागोरस। सो डिफिकल्ट टू इमेजिन बिकॉज यू हैव नो प्रैक्टिस, इसलिए बोलते हैं पढ़ो। कॉमर्स हमेशा खुली हुई है तुम्हारे जैसे बच्चों के लिए, ये मेहनती लोगों का टॉपिक है भाई, असाइनमेंट करने वालों का। मैं बोल रहा हूँ रिजल्टेंट एंड यू आर सेइंग N2, पाइथागोरस लगानी थी सिंपल। ओके, all right, so let's do one more question again from NCERT, but this time bit tricky type of problem. So this is your x-axis. Just be very vigilant when you solve basic questions यार। पिछली क्लास को पढ़ के आना चाहिए आपको कि okay, I've understood whatever was taught. Now there is a particle which is released from point P. Okay, let me open up NCERT and paste the question first. Okay, let me just copy, थोड़ा लेंदी क्वेश्चन है, लिखना मुश्किल हो जाएगा। This is a problem which will sound very JEE mains type of problem. Very basic though. Question number, लैडर वाला हमने कर लिया, एनसीईआरटी में है। I'm sorry. Rolling motion, lengthy chapter.
सर आपको क्या जुकाम हो गया क्या?
Something is irritated my throat. I don't know what is it. Suddenly it has struck me. अभी तक तो नहीं था कुछ भी. चला गया.
सर मैंने एक एलिवेटर बना दिया.
What is that?
अरे व्हाइट बोर्ड पे देख.
Show me.
ये देखो.
Okay. Okay, so now the point, there is a point here. Okay, so there is a point, this is the point. And this point P comes down straight, okay, downwards. So it comes from here.
Down.
Yes, yeah, downward, exactly. So I'll just draw an arrow to show that. This, yes, so it goes down like this. And so it is falling along y-axis vertically. So this is y-axis, and y-axis is this, and this is x-axis. This is theta.
अच्छा.
This is r. Okay, and let me just see, ऐसे गिर रहा है. And so the mass is m of the body which is falling down, and from the point it is falling, this distance is given to be x naught. So you can see if the axis is the y-axis about which it is falling. So this is your axis, okay? And you can see the perpendicular distance of the point when it is falling down from that axis is x. The question is, what is the torque acting on the particle at time t when it is at a point q? So
हमारा
ये q पे
पार्टिकल
जब, हाँ ये
तो गिर
पार्टिकल,
रहा है.
हाँ नीचे की तरफ जा रहा है, और ये नीचे गिरते 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 it reaches a point q. Okay, so I'll just show you the point q using this. Okay, so let's pull it down. Let's pull it down and let's connect this. ये connect हो गया, okay?
ये देखो सर.
I think इसको हमें थोड़ा सा लंबा कर लेना चाहिए. Yeah. ये q है. q पे when it reaches q, you have to find the torque which is acting on the particle after time t when it reaches q point.
दिस इज क्यू.
This is q, correct.
ठीक.
Time
यानी
t
कि
लगता
आपका
है इसको पहुंचने में. So this is your time t.
अच्छा दिस इज क्यू.
Yep.
क्यू.
Yeah. And the time elapsed is t. It is going vertically with the help of gravity, obviously. It's like a free fall which is happening. You have to
mg.
find the torque
जी.
and with respect to origin. The torque has to be found with respect to the origin. Find the torque with respect to O.
Talk with respect to O. Where is O? This is O.
Origin.
अच्छा. The force being experienced is mg.
Yes, that is
And
correct.
x naught and
So F is known to you. If you
हाँ
write
जी,
the formula of torque, which is R cross F,
हाँ जी,
position vector is R.
yeah.
You can see the position vector OQ.
परपेंडिकुलर डिस्टेंस है, ये क्या है, ये y है, अच्छा ये y है,
This is y-axis. It is falling
y
freely.
एक्सिस,
Mg is continuously getting applied. The position vector is R OQ. So OQ is the position vector R.
सर यहाँ पर भी इसको कोई पॉइंट मान ले क्या,
किसको?
यहाँ से जो
हाँ हाँ, x नॉट है ये.
ये x नॉट हो गया,
ये x नॉट है लेंथ. इसके
हाँ जी,
कोऑर्डिनेट्स हैं y एक्सिस में, तो जो भी हैं टाइम t में होंगे. s इज इक्वल टू ut प्लस हाफ जी टी स्क्वायर. तो ये हाफ जी टी स्क्वायर कॉमा x नॉट कॉमा हाफ जी टी स्क्वायर. So it is released at from rest.
ठीक,
इसके coordinates time t में ये हैं.
हम्म,
What is a talk about? Oh, this is a particle, remember. It's a particle, MVR, R cross F. Torque is R cross F. You have to find the vector product of the position vector and the force. You can write both of them vectorially also, but you know the angle between them is a
मतलब वो निकाल है ना, क्या कहते हैं,
torque.
परपेंडिकुलर डिस्टेंस,
You can also write this. The torque is given by R F n sine theta.
ठीक है, okay. And what is the like the perpendicular distance?
The perpendicular distance is x naught.
ये वो तो
Either
ठीक,
use the formula R F
cos,
into perpendicular distance, or use this formula. This is also R sine theta is the perpendicular distance.
x नॉट, क्या कहते हैं, mg x नॉट,
Which formula are you applying? That's my question to you first.
r cross f, r into
So
f,
R cross F में तो perpendicular distance नाम का word ही नहीं लिया तुमने. That is a vector format. That is a formula of angular momentum or what? Torque, right? R cross F.
हाँ जी, टॉप,
ये लिख दिया. So इसमें perpendicular distance कहाँ पे है? Word कहाँ है? R is not a perpendicular distance. R is the position vector.
हाँ जी,
R दिया हुआ ये रहा. OQ. OQ vector is known. So decide what are you saying. The magnitude of torque is magnitude of R into F into R sine theta. R sine theta is the perpendicular part of the position vector.
ठीक,
तो ये वाला अगर R है, इसका perpendicular component कौन सा है?
परपेंडिकुलर x नॉट,
Yes.
नहीं सॉरी सॉरी,
हाँ, x naught.
हाँ जी,
लाइन ऑफ एक्शन ऑफ फोर्स कौन सी है? वो भी नहीं बनाई. शो द लाइन ऑफ एक्शन ऑफ फोर्स. दिस इज योर लाइन ऑफ एक्शन ऑफ फोर्स.
ये वाली,
हाँ. So the line of action of forces, and this is your perpendicular distance.
x
And
नॉट,
if you notice, x naught कितना है equal to r sin theta ही तो है.
हाँ जी,
Theta is given. Theta ये है. तो ये कितना होगा r की टर्म्स में? अगर ये हाइपोटेन्यूज है और ये थीटा है, तो ये कितना होगा?
r sin थीटा, हाँ जी, और हमें
तो
टॉर्क हमें
डिसाइड
क्यों
कर
मिला?
लो what do you want to do. Either you want to use this or you want to use vector format. Please decide what are you trying to do.
ठीक है, this one, r f and sin theta,
So you're finding the magnitude then.
हाँ जी,
तो r sin theta perpendicular ही होता है. The
ठीक है,
perpendicular part of
तो
r which is
mg
perpendicular to line of action of force.
mg x नॉट,
जी. अब उसकी डायरेक्शन बता दो वेक्टर फॉर्म में. चलो, okay, so let's stick with this. You worry about only the first part, okay? So this is correct. ये समझ में आया हुआ कैसे कि नहीं आया?
नहीं नहीं, ये समझ
That's
आ गया।
okay. This is clear to you, right? So second part is which you have to find the angular momentum of this particle at this time, again about O. Now you find L, angular momentum, which is
MVR,
R cross P,
R cross P.
but magnitude निकालना है हमें.
Hmm.
My magnitude is again R P sin theta. So P के perpendicular R का वो वाला component जो P के perpendicular. So you can see P is this, right?
P x naught.
So I know P. What do you mean P x naught?
मतलब
R sin theta is already known to us. And P is how much mass into velocity?
yes sir.
And velocity is GT.
G
U is 0.
तो M
Hmm,
MGT x naught.
right, आ गया.
ठीक है।
ठीक है?
Yes.
Third question. Prove that in this situation prove that the torque is equal to dl by dt. So whatever expressions you have found out, use them. आपने L निकाल लिया? L. Take the derivative and show that it is equal to t. If you take derivative of this equation,
Hmm. ठीक है। तो इसको हम ऐसे लिख सकते हैं x नॉट m x नॉट g into
what is t equal to? Tau है ना ये तो?
टाउ है। हाँ जी
But you have written t. What is
सर, वो
t?
मुझे लिखना नहीं आता टाउ कैसे लिखते हैं।
Okay. ये ऐसे लिखते हैं.
कैसे लिखते हैं? अच्छा ऐसे।
Yes.
You mean this?
Yes.
This is टाउ। अच्छा
This looks like inverted J. Dyslexia तो नहीं है. It is on the right hand side, buddy. You're drawing on the left hand side. This. You know what is dyslexia? उसमें उल्टा
हाँ जी
लिखता
सर, पता है मुझे, पता है।
तारे जमीन वाला केस तो नहीं है ना?
नहीं नहीं
डिस्कवरी हो जाएगी भैया.
नहीं,
I know how to teach a dyslexic. Added qualification. dl by dt, sorry यार. ठीक है, टॉक का एक्सप्रेशन लिख लो. यहाँ t था ना, mgxt.
हाँ जी। अरे
Now take derivative of both the sides. D will go. D tau by t लिख दो बस t. And please write magnitude. Don't write this vector. We are just worried about t. निकाला तो है ऊपर.
हाँ वही है।
ठीक है. Take derivative of both. Take derivative of this.
वो
तो
तो
L जो निकाला था सेम आ जाएगा. L आ जाएगा.
टी वैसे भी कैंसिल
ये L है यार. ये tau तो लिखा ही नहीं. This is L. You're writing the expression of L and writing it equal to tau, which is very weird.
नहीं, मुझे वो डेरिवेटिव लिखना था।
नहीं, but derivative तो L का लेना है ना. The derivative of L
वही
has
ले
to
रहा
be
था मैं
taken.
अभी।
तो ये L लिखना चाहिए ना फिर.
अरे यार
This is L. Formula is of L. You're writing tau there. Why?
मैं m एक्स नॉट जी टी का डेरिवेटिव ही ले रहा था।
हाँ, बट वो टाउ होता है, पहले लिखो L इज इक्वल टू,
अच्छा जी,
then
ठीक।
take if you take derivative of tau, now tau is equal to dl by dt. G. This is capital L, by the way, okay? Preferably write capital L for,
आई हैव डिसलेक्सिया सर।
yeah, good. पेपर शुरू करना ऊपर लिख देना आई एम dyslexic.
यस, कॉग्निटिव डिसेबिलिटी।
Yes, nothing wrong. मैं था मेरे ख्याल से, I was dyslexic.
तो ये आ जाएगा सर एम एक्स नॉट
Hmm.
जी।
Right. Proven. So indeed we had the talk as this, right? जो हमने ऊपर निकाला था. Proven. All right. Let me go to the next page. Initially, it's a very painstaking process, but finally, I think it is. So let's talk about one more case where the mass of electron is given to be
सर कोई ऐसी कोई
9.1.
ड्रग आती है जिससे लाइक कॉन्सेंट्रेशन बढ़ जाए?
No,
तो,
exercise is the one. Yoga, good diet, exercise, and some entertainment. Sports, R is equal to 0.53 this. So there is a nucleus, and around the nucleus you have an electron which is revolving. So this
okay.
is the electron which is
कौन
so
एटॉमिक
this,
फिजिक्स,
yes,
एटॉमिक
exactly.
फिजिक्स।
So this is your nucleus. Okay. And question is
नॉट
the,
क्लासिकल फिजिक्स नाउ,
yes, modern physics.
एटॉमिक फिजिक्स।
Modern physics. Okay. And the velocity of this electron is given to be 2.2 into 10 raised to power 6 meter per second. You have to show that the angular momentum in this situation, which is obviously MVR because it's circular,
अच्छा, दिस इज आर, ओके।
V, and this
मुझे कुछ
is
तो सर, मुझे
R.
कुछ स्ट्रक्चर ऑफ एन एटम वाली चीज याद आ रही है, पता नहीं
Very
क्यों।
similar, yes. So you have to find L first equal to MVR.
हाँ हाँ,
Okay, sine is
निकल
90,
जाएगा।
sine 90 है, आ जाएगा.
आ
And
जाएगा
now
सर,
you
ये
have to show,
9.1 इंटू 10
hold on,
माइनस 31।
right? You have to show that L which you get is same as h by 2 pi. So this postulate that the angular
ओह,
momentum of the electron is h by 2 pi. We have studied in
यस
chemistry.
यस, ओके, दिस इज द प्लैंक्स
Planck's
कांस्टेंट
constant 6.63 into 10 raised to power minus
ओवर।
34 divided by 2 pi, 2 into 3.14. If you actually do
यो,
this calculation of MVR for the electron, the angular momentum, you will actually
ओह,
get it equal to, and by the way, I think this इसने दिया नहीं, but I think n is equal to 1 का केस है ये, because nh by 2 pi होता है, तो n1 लिया हुआ है इसने, तो फर्स्ट प्रिंसिपल क्वांटम नंबर के हिसाब से वो निकाला है इसने
अच्छा,
एंगुलर
द
मोमेंटम,
द लाइक द फर्स्ट ऑर्बिट,
quantized,
फर्स्ट बोर
yeah,
ऑर्बिट।
quantization of.
यो,
So you just need to do this MVR,
ठीक है,
calculate
वो उसके
MVR,
लाइक वैल्यू
yes,
प्रूव
and
कर
then
दे,
compare it
ठीक।
with h by 2 pi.
ठीक है, यो, दैट्स अ कूल क्वेश्चन।
Yes, it is. Okay, let's move to the next one. So you have a
एटॉमिक
particle.
फिजिक्स।
Yes. So next question is you have a particle whose mass is given and m, and the trajectory which is followed by the particle
आपके
is
हाइजेनबर्ग आ
equal to,
जाएगा।
no, अब नहीं, 10 alpha t square I plus 5 beta t minus 5 j. Okay, alpha and beta are constants.
ठीक है,
Numbers, some numbers are there, right? Your question is this is the and so time dependence position vector is there,
हाँ तो डेरिवेटिव।
right? Question is find, and the angular momentum of the particle is, angular momentum of the particle is same as it was for t is equal to 0 at time t is equal to how many seconds? This is what you need to find out.
तो वेलोसिटी निकालने के लिए डेरिवेटिव ले ले क्या आपका?
पहले, have you understood the question? We are not talking about maths. Have you understood what are we trying to do? What's a rush of taking derivative and all of this? Maths का question थोड़ा ना दिया. Physically, what is happening? So you have R and you are being asked the angular momentum of the particle becomes the same as it was for t is equal to 0 in how many seconds? So angular momentum repeat हो रहा है, वापस आ रहा है जो t इक्वल टू 0 पे था, वही वाला एंगुलर मोमेंटम आपको ढूंढना है किसी और टाइम पे. सो एंगुलर मोमेंटम इज रिपीटिंग इटसेल्फ. सो वो कौन सा टाइम है जब एंगुलर मोमेंटम दोबारा रिपीट हो जाएगा?
हाँ.
The angular momentum of the particle becomes the same as it was for t equals 0 in how many seconds? So first of all, worry about, with the help of a position vector, how do you proceed with this? R is known to you for, so if you write angular momentum like this, L is equal to m r cross v. This is L. How will you find now v? अगर position vector मालूम है तो dr by dt is v. If you know r, what is this? This is dr by dt.
ठीक है.
Put the values now, डालो.
And
Put the value in L.
14.
Then calculate what is the value of t, angular momentum at t equal to 0. देखें कितना आता है.
ठीक है, डाल लो.
पहले just calculate v first.
हाँ जी. ये हो जाएगा 20 अल्फा टी
Hmm.
आई कैप
Hmm.
प्लस 5 बीटा
Right. ठीक है. J.
जे कैप.
ठीक है. Done. So you know v now. Put it here in the concept L. Question is angular momentum repeats at t and at what other time? So first let's find at t equal to 0 what it is. So mrv, okay, put value here. Find the vector product also of r and v. We have already found v. So you know v equal to, ठीक है.
जीरो डाल देना, पहले जीरो डाल के देख.
पहले क्रॉस प्रोडक्ट निकालो ये, फिर उसको इक्वल टू 0 डालो.
ओके,
You have to find the cross product of r and v.
ठीक. पहले क्रॉस मॉडल क्रॉस डिटर्मिनेंट बना लो.
Yes.
और 10 अल्फा टी स्क्वायर
I don't think so. There is a k.
नहीं, के इसको मैं जीरो डाल रहा हूँ ऐसे.
अच्छा.
आई तो खैर जीरो ही आ जाएगा.
जी.
बस जे भी 0 है,
हम्म,
के कैप में डायरेक्शन है।
जी
10 अल्फा टी स्क्वायर इंटू 5 बीटा माइनस 5 बीटा इंटू टी माइनस 5
जी
इंटू 20 अल्फा टी
दैट्स योर एल
एल, which is whole equals to 0%, है ना?
बट कलेक्ट हाँ इट इज इक्वल टू 0 यस
50 अल्फा बीटा टी स्क्वायर
ठीक है कोई फैक्टर बन जाएंगे ओह
सो बीटा
ओके
बीटा कॉमन आ रहा है 5 क्या कहते हैं 50 बीटा
ठीक है ले लो
बाहर ही लिख लो इसको पूरा,
हम्म,
अंदर फिर बचेगा अल्फा टी स्क्वायर 20 टी प्लस 10
हम्म,
इक्वल्स टू 0.
yes okay this cannot be 0 yes alpha is still there
हाँ जी,
okay I think r cross v ये नहीं आना चाहिए था अल्फा अल्फा शुड नॉट हैव बीन देयर क्योंकि
हमने
फैक्टराइज नहीं
कुछ
होगा नीचे
कैलकुलेशन मिस्टेक कर दी है.
यस 100%
अल्फा
देयर इज एन एरर बिकॉज अल्फा नहीं बचना चाहिए था नहीं तो फैक्टर कुछ वी कुड हैव डन समथिंग विद दिस अब तो बिल्कुल नहीं हो पाएगा कुछ भी व्हाट इज योर v इक्वल टू 20 अल्फा टी प्लस 5 बीटा जे सही आया r क्रॉस v करने पे क्या आया यू हैव
10 अल्फा
डन
टी स्क्वायर इंटू 5 बीटा
दिस इनटू दिस जीरो अच्छा सिर्फ यही सॉल्व करा है इससे आया 5 बीटा t माइनस 5 इंटू 20 अल्फा t हाँ तो व्हेन यू ओपन दिस ये मल्टीप्लाई तो करा ही नहीं यू हैव नॉट मल्टीप्लाइड देम सेपरेटली
हाँ जी, वो वही मैं कर रहा हूँ. सो
I think 100 alpha t square will go
भाई
100
बीटा को
alpha
मैंने ले क्या इसमें से पूरा,
हाँ वो इजी हो जाएगा थोड़ा यस यस अल्फा
अल्फा
भी कॉमन आ ही रहा है सब में ये अल्फा बाहर आ जाएगा ये वाला ये अल्फा विल आल्सो गो
5 अल्फा अल्फा बीटा.
यस अल्फा बीटा एक्चुअली इज आउट
हाँ जी,
नाउ दिस इज
5
10t square and 5 अच्छा 5 भी गया सो ओनली 10t square एक्चुअली
10 टी स्क्वायर
हाँ जी
into t minus
जी
20t
हम्म
minus 100
यस
equals to 0. Right, alpha beta is equals to 10t square minus 20t plus 100
10 कॉमन
t square minus 2t plus 10. तो सर irrational रूट से आ रहे हैं. अजीब से ही आंसर आ रहा है.
फैक्टर नहीं बन रहे अब
नहीं, वो अजीब से बन रहा है. -2 plus minus under root minus 36
नहीं दिस इज कॉम्प्लेक्स हाउ कैन यू गेट अ अनरियल रूट यार ये तो हो ही नहीं सकता
minus 2 plus minus 6 iota
करने का
upon 2
फायदा नहीं है आयोटा होता ही नहीं है तो सो यूजलेस
plus minus 3 iota.
समझ नहीं आया so you multiplied 5 beta into 5 this is right 5 beta t minus 5 ठीक है 10 अल्फा टी स्क्वायर इज फाइन ये दो बार ये 5 बीटा कैसे आ गया दोबारा
5 beta सर ये मल्टीप्लाई हो ना 5 beta into alpha t 10 alpha t square.
अच्छा 5 बीटा इंटू अच्छा ओके एंड देन 20 अल्फा टी 20 अल्फा टी ये क्या है 20 अल्फा टी
हाँ जी, अल्फा कॉमन आ गया सर.
no wait so if I
एक
were
मिनट,
something is wrong
there's
man
some blunder,
हाँ
major blunder. सर टी खा गए हम.
किधर
यहाँ मैंने टी नहीं लिखा.
वेयर शो मी
या इधर
नहीं नजर आ
20
रहा
alpha t, it should be 20 alpha t square and t.
अब ठीक है यस
अब तो हो ही गया बस. minus 10 t square 10 100 t
राइट
k cap minus t plus 10
यस
is equals to 0, t equals to 10 seconds.
ओके
आगे क्या करना था?
Put it equal to 0.
हाँ
इसमें एक t कॉमन भी तो आया था.
हाँ, वो कहाँ
So
सब
t is
अक्कल
equal
किया।
to 0 and the same momentum will come at t is equal to 10. So angular momentum actually becomes equal to 0 at two places. At t equal to 0 and t is equal to 10 seconds.
कैलकुलेशन मिस्टेक हो रही थी बार बार। ठीक है सर।
Okay, next page. Try this. Same question of equilibrium written in a different language.
वेट ऑफ द लैडर 10 kg,
Yes.
अगर जी 10 है तो नॉर्मल रिएक्शन यहाँ से आ रहा है। N1 N2 FK हमें परपेंडिकुलर डिस्टेंस नहीं पता, मतलब सॉरी ये नहीं पता हमें, कहते ये दो चीजें।
Why is this K here? This is
के
static friction and this is K.
ओ, मुझे ऐसे लिखना था, आई हैव डायलेक्सिया।
Between ladder and the floor. Okay. थीटा पे तो इस समय भी इक्विलिब्रियम पे है, ठीक है. राइट, तो ये जो भी थीटा होगा, सो दिस विल बी 8 sin थीटा एंड दिस विल बी 8 cos थीटा. If theta is not known, then this is 8 cos theta sin theta and this is 8 cos theta.
तो एंगल निकालना है वैसे।
हाँ, तो let that angle be theta ना.
हाँ, अज्यूम कर लिया। इसके सेंटर पे है
हाँ.
वेट।
Okay. Now apply all the three equations. Sigma fx equal to 0, sigma fi is equal to 0, and torques equal to 0, which means LHS equal to RHS.
Hence,
Answer. राइट इन एक्स एक्सिस में क्या क्या लग रहा है n1 इज इक्वल टू एफ एस n1 इज इक्वल टू एफ एस n2 एफ एस इज इक्वल टू म्यू n2
mu into 100.
n2 दिया हुआ है अच्छा आई डोंट थिंक सो n2 इज नोन अच्छा बिकॉज द वर्टिकली n2 इज इक्वल टू दिस
हाँ जी
यस वो भी लिखना चाहिए so
हमें
you should first write that to show that you have taken
which
care
is
of y axis
40.
if you write like this you will not get marks in school
अच्छा जी
यार वो तो फर्क ही नहीं पड़ता चलो कोई फर्क नहीं पड़ता
n2 is equals to okay sorry 100. So n1 equals to 40 Newton and n2 is equals to 100.
yes
Hey man, how it's 40? Low. Okay, it's 40. ठीक है। अब ये तो हमने निकाल लिया
I think we just did this question
हाँ
few
जी
minutes back identical question
yes sir. Now n1 into
torque नहीं लगाया you have not applied torque as
हाँ टॉर्क ही लगा
about some point
टॉर्क तो n1 into 8 cos theta तो 0.4 आ रहा है 10
okay you can see the table of tan and find the angle tan theta is equal to 4
0.4 नासा वालों का मिल गया मुझे
0.4 है ना
it is 22 degree
0.4
हाँ जी तो 22 डिग्री
हाँ ठीक है n1 multiply by n1 about what point have you taken the torque लिखा नहीं कहीं पे n1 into 8 cos theta so around which point have you taken n1 8 n1 को 8 cos theta से मल्टीप्लाई करा अच्छा
नहीं आई गेस मैंने उल्टा कर दिया
हाँ गलत है
उल्टा कर दिया मैंने गलती से
yes you have not written which point talk about which point is being considered
मैंने गलती से उल्टा लिख दिया सर मैं इस पॉइंट पे ले रहा हूँ ये ओ ये Talk about a point O.
Okay. 8 sin theta है वो.
Torque about O. Um, 2.5.
2
So
point.
68 degree आ गया.
Yeah, roughly yes. 68 and a half. 68 is better. So you found about n1 into about this point. So you 100 into n1 and n2. What happened to this?
This ही.
जो वेट है 100 न्यूटन्स का वो कहाँ गया?
वो तो लिया N2 100.
अच्छा वेट इज 100. ओके करेक्ट. सो n2. सो n1 ले लिया, n2 ले लिया और ये दोनों कैंसिल हो गए. सो n2 is equal to n1 is how much? 40. n1 by n2 is equal to tan theta. n2 by n1 is equal to cot theta. Tan theta is equal to 10 by 1. ठीक है. Got it. Right? ठीक है. We will do some more questions on this topic. Let me think if I can get some more questions. ठीक है. See you on Monday then. And please do practice.
वैसे एक्चुअली लेजिटिमेट मेरा सोने का टाइम होता है.
9 बजे? Are you kidding?
Yes, not kidding.
And what time do you get up?
Sir, I get up this 7.
Okay, 10 hours you sleep. Okay. ठीक है सेज में इट्स फाइन. स्कूल कितने बजे होगा?
मैं स्कूल नहीं मतलब जैसे जब यूजुअली स्कूल होता है तो 9 बजे सोता हूँ वैसे.
अच्छा अच्छा.
नॉट लाइक सैटरडे संडे और फ्राइडे नहीं जल्दी नहीं सोता.
ठीक है. चलो enjoy.